Hello and welcome to the second video on our Introduction to Screen Readers. Hi, my name is Jason and I work for Rutgers Access and Disability Resources. So in the last video, we looked at how a student who is blind or visually impaired that uses a screen reader might navigate through your content. And in this video, we're going to look at how they would actually consume that content. So for many of you, you may be using beyond text. You may be utilizing graphs, tables, maybe even complex math. And this recording is going to go through each of those items to show you how a student would access that from their point of view. So I'm going to be utilizing a program again called NVDA. So hold on one second.
Welcome to NVDA dialog. Welcome to NVDA. Most commands for controlling NVDA require you to hold down the NVDA key while pressing Most. Welcome. OK. OK. Faculty Accessibility Training. Graphic Stark Industries logo. This is a mock page.
So to record this video, I have to use both my laptop with the software on it and my desktop to record. And so I'm going to go pause the screen every now and then to interject. So what I did just now is I opened up NVDA, and this allowed me to show you now two versions of the same page that I've created online, and we're going to look at the inaccessible version first.
So this is a mock page to examine how accessibility impacts faculty accessibility training. Firefox nightly. Faculty accessibility training. This is a mock page to examine how accessibility impacts the manner which an individual who is blind or visually impaired would interact with content. Heading Level 1 Overview on Space Shuttle Prototype. Stark Industries has built its first Space Shuttle prototype. It is our hopes to explore strange new worlds, to seek out new life and new civilization, to boldly go where no man has gone before. By 2025, our company, in conjunction with SpaceX, will launch its first flight to the Pegasus Galaxy. Heading Level 2 Cost of shuttle launch. Historically, the cost of launching a rocket averages 100.
So as you can see, what happened was that the screen reader itself did not read the images. What happened was it came to this point here, and it read the header 1 overview of space shuttle prototype, and then it skipped the image altogether. And so what that means is, if I was a student with a disability, I may not have known that there was even an image there. So we're going to continue reading.
Elements list dialog. Tree filter by. Tree view. Type. Group headings radio button check alt plus H. Form fields. Heading tree view. Comparison of engines in similar crafts 2 on 2 left. Comparison of engines in similar crafts. Table with 6 rows and 3 columns. Row 1 column 2 engine type. Column 3 horsepower. Row 2 column 1 F2A3. Column 2 right R1800 and column 3 1200. Row 3 column 1 F4 F3. Column 2 P and W are 1830-86. Column 3 1200. Row 4 column 1 F6 F5 N.
So what you just saw was that while the page is navigatable, so I was able to jump down to our second heading of comparisons of engines and similar types of similar crafts. How it read that table in this inaccessible version was it read column 1, then the text in column 1, column 2 and the text in column 2 and column 3 and the text in column 3, which if you're looking at a simple table with 1 or 2 columns, you may be able to remember, okay, column 2 is engine type. But if you're looking at something more complicated, like a z-index table or a table with, let's say, 5 columns, be able to keep in your mind, okay, I'm now on the the 5th row, and this column in this row now pertains to the type of engine and the horsepower, right? And so it becomes difficult visually in your mind to keep track of where you are on that table. And later when I show you how it's read on the accessible version, you'll see how much easier that is. So the next type of content we're going to consume is math.
Migradium technology. As you can see. F6, F5, N, row 4, 2, row 5, column, row 6, column 1, N dot, column 2, warp drive, column 3, 9.9, out of table. As you can see, our engine is far superior to anything on the market. It utilizes our warp reactor. With cutting-edge Migradium technology, below is more complex math to make our funders think we know what we're talking about. Blank, 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 blank.
So in this case, what ended up happening was that the screen reader got to the math and just said blank. So in the other case where we got to an image of the chart, the screen reader skipped it altogether, and so as a user, I didn't even know there was information there, important information that I need to know about the comparison of the rocket launches. In this case with the math, because it was encoded correctly, what happened was that it just read it as blank. And so for a user trying to learn math using a program like MyMathLab or MyAccountingLab, or even online tools to submit homework, if the math isn't coded correctly, it can make it very difficult. So I'm going to show you now what the page should be read like if it was coded correctly.
Impaired would interact with Stark Industries logo. This is a mock page to examine how accessibility impacts the manner which an individual who is blind or visually impaired would interact with content. Heading Level 1 Overview on Space Shuttle Prototype. Graphic image on the U.S. Enterprise spaceship with model number NCC 17110. Stark Industries.
So as you can see in that example, the screen reader read that image, and what happened is on the back end, because it was tagged as a image of a spacecraft with model number NCC-1701-0, it was able to then read that metadata information on the back end. So we're going to look at now how it reads that table down below, the chart. Sorry.
Elements list dialog. Level, cost on shuttle launch. Heading Level 2. Heading Level 2, cost on shuttle launch. Graphic bar chart on history. Rocket launch costs with launch cost millions. Inflation adjusted to 2015 on graphic the y-axis and year on the x-axis. In 2006 the Soyuz rocket cost 71 million and the Atlas V cost graphic 118 million. In 2015 the Soyuz rocket cost 210 million, the Atlas V cost 164 million and the graphic Falcon 9 cost 71 million. Source: United Launch Alliance, NASA, SpaceX, ARK Investment Management Graphic LLC. Historically, the cost of launching a rocket averages $150 million US dollars. Our spec engine type column 2 right R1000.
So in that example, what we saw was that it got down to this bar chart, and then it read out loud the information we coded in the back end. And in another webinar, we'll go over how to create an alt text But the purposes of this webinar is to get you to understand how that student would consume the information and what they would hear. There are other ways of representing graphs and bar charts. Another way we typically might provide this information is in swell format. The way that works is we would create the image and we would use special paper and special materials to then have that image be raised on the paper so that the student can then feel the graph. There are also other ways of hearing a graph using sound and pitches and volumes to indicate changes in the way the graph may dip or rise. Those are just some ways that a student who is blind might be able to access this information. So we're going to continue down on our page and read the comparison of similar aircrafts and how it reads a table that is coded correctly.
Elements list dialog. 3. Comparison of engine. Heading level 2. Comparison of engines in similar crafts. Table with 6 rows and 3 columns. Row 1 column 1 type of plane. Column 2 engine type. Column 3 horsepower. Row 2 type of plane. Column 1 F2A3. Engine type. Column 2 right R1820 40. Horsepower. Column 3 1200. Row 3 type of plane. Column 1 F4F3. Engine type. Column 2 P and WR1830 86. Horsepower. Column 3 1002.
So as you can hear, what happened was when the table is coded correctly, it read the table headers, so that it said type of plane, and then it read the information within that column. So F4, F-3, and then when it got to the next column, it read again the header on the column, engine type, to let you know that that's what this information pertains to. And if there was a more complex table with row headers and column headers, or if it was a large table of 20 rows and 20 columns, it'd be easy for the student to quickly identify what information in that cell the screen reader was referring to. We're going to now jump down to the math, and this is especially important for all those professors or individuals who are teaching STEM content that have math. I'm going to show you how this screen reader reads these equations.
1000 row 4 type engine horse row 5 engine horse row 6 engine horse outer with cut. Below is more complex math to make our R sum I K N sum with cut. As you can see, our engine is far superior to anything on the market. It utilizes our warp reactor with cutting edge vibranium technology. Below is the formula for how we calculate our warp speed. R sum I K N sum minus 1/2 G sum I K N sum R plus lambda G sum I K N sum equals negative kappa T sum I K N sum. Below is more complex math to make our funders think we know what we're talking about. The integral from 1 to the square root of 2 on the fraction with numerator px and denominator x squared times the square root of 4 minus x squared.
So depending on the type of screen reader a student uses, the browser and the version of the browser they're using, the screen reader may read the exact same equation on the exact same web page 3 different ways. Math in general requires a lot of work to make accessible. And so when we provide this to an accessible, when we provide an accessible version to the student, what we typically will do is let them know all those 3 criteria that we need them to access this information in. So what browser they need to use, what version of the browser, and what screen reader, and what version of the screen reader that we've tested this in that it works. Important to know on math, what would help us greatly to be able to convert this math into an accessible format is if we were able to provide it in LaTeX. LaTeX is a language for typing out math using syntaxes. It's very similar to HTML. And what it does, it takes those syntaxes and it creates a graphic representation of what those syntaxes are. So for example, you would use a tag to create the limit sign, and then it would output this limit sign here. And then we use a specialized process in which we turn that LaTeX into MathML using a plugin called MathJax. You don't need to know how to do that. I will create another video on how to provide math content to us if you don't know LaTeX. The purpose of this video, though, is to get you to understand how a student who is blind would consume your math equations. So that is our tutorial on consuming content. Thank you so much for watching. If you have any questions, feel free to reach out to our office.